Good problem. Number 9. A bacteria culture double in 18 hours. So we're going to start with the formula A equal PE to the RT. So if we start with 1, we want it to double, and we want to look at the rate at which it's doubling, and it's doubling every 18 hours. And so if we want to solve for R, I want you to ln both sides, and so that will give you 18R, and R is going to equal ln2 divided by 18. So the rate at which it's doubling, it's going to be 0.0385. Now we're going to try to answer the question. The question is if 2,000 bacteria were present at 12, and so we're going to start with the same formula. We're starting out with 2,000 bacteria. We have the rate at which it's growing, which is 0.0385. And we want to look at it from 12 noon to 6 p.m. 12 noon to 6 p.m., that's the time of 6 hours. And so if you go to your calculator, do all of this in the calculator, and then round your answer, you're going to have 2519.8 bacteria. Now, there's two different ways you can round this problem. I prefer you to round it to 2519 bacteria, because you're not going to have a 0.8 of a bacteria. However, if you give me 2520, it's still acceptable answer. We're fine. Number 10. As soon as you see compounded semi-annually, when they use the word compounded semi-annually multiple times per year, you know n is equal to 2. I need you to use this formula. P times 1 plus R over n to the nt. Now, we're starting out with $4,000. We want this amount to be $6,800. We already know the rate at which it's invested, 0.06. The n is 2, and we're looking for time. Now, what I want you to do to solve this equation, divide by 4,000 on both sides, and this is going to give us 1.7 is equal to 1.03 to the 2t. Now I want you to log both sides. To solve for t, we're going to log 1.7 is equal to 2t log of 1.03. Solving for t, dividing both sides by 2 log of 1.03, and so t is going to equal to log 1.7 divided by 2 log of 1.03, and we're looking for time. It's going to give me 8.97, or simply you can say it's 9 years. You'll be fine. Either one of those two answers will be good. Number 11, again, is a compounded quarterly formula. So that means n equal to 4. Again, the formula is A equal P times 1 plus R over n to the nt. So we're starting out with $25,000, and 1 plus R, the rate is 0.08 divided by 4, and this is for annual n time 8.5. Go ahead and use all of this on the calculator, and be careful and learn how to use your calculator. And I got 49016.9. Okay, number 12. We have the population when it started at 0, it's 5,000 people. 2 years later, it was 6,500 people. I'm going to use the A equal PERT. And so when you start out with 5,000 and ended up with 6,500, we want to find out the rate at which is increasing. If you divide by 5,000, and you will know that this is 1.3 is equal e to the 2r. ln 1.3 is going to give you 2r, and then if you solve for r, r is equal ln 1.3 divided by 2. Be careful here, you're looking for rate. 4 decimal places gave me 1312. Now let's go ahead and answer the question. The question is, we want to figure out when is the population going to be 16,500. So I'm going to start with the same formula, which is PERT. And now if I started out, if I wanted 16,500, and this is 5,000 E to the negative, I'm sorry, it's positive, 1312 times t. I want you to divide by 5,000. And then what you end up with, this is 3.3 is equal e to the 0.1312 t. ln 3.3 is going to give you 0.1312 t. Solve for t. I got 9.1 here when the population grew from 5,000 to 16,500. If you wanted to know from 6,500 to 16,000, that will be only 7.1 years. And so that will be minus 2 years. Okay, number 13. Number 13, I'm going to use the same formula, which is PERT, PE to the RT. So if the present cost is $150, the rate of inflation is 0.05 for 7 years. If you calculate all of that, this is going to be giving me $212.86. We're dealing with money. 2 decimal places is good. Number 14. Number 14, I'm going to use PERT again, E to the RT. If the present population is 3,500, we want to know what the population was 5 years ago, and this is a decline, so this will be negative 0.07 times 5 years. Your job is to solve for P, so I need you to figure out what that number is and divide both sides by it. If you divide both sides by E raised to the negative 0.35, E to the negative 0.35. Okay, solving for P, and P you're going to have a 4,966.74. This is a decline, so it started about 5,000 and then now it declined to 3,500. Number 15, I'm going to start with the A equal PE to the RT. I need you to know it's a half-life, so if you started out with 1, we're going to go to half of that. E, we need to figure out the rate of decay, and it takes us 0.75. 0.75 is 3/4 of the hour, which is 45 minutes. And so if you ln both sides give you 0.75 R. And then R will give you ln 0.5 divided by 75. And R is going to give us negative 0.9242. I need you to know negative because it's a decay. Now we're going to try to answer the question. And so if I start with the formula again, we're starting out with 15. So A is equal to 15. We already know the rate at which it's decaying, 0.9242. And the hours is 1.2. And so now if you calculate all of this on the calculator, I got 4.9482. Any variation of this 4.95 will be good. This is how many grams, which is option D. 16, compounded quarterly N is equal to 4. We have no choice but to use this formula. This is the only formula that's compounded multiple times per year. And so now if we started out with if we want the amount to be 14,000, started out with 5,000. 1 plus the rate is going to be 0.08 divided by 4 raised to the 4t. Now how do we solve for t? So what I'm going to do, I'm going to divide by 5,000 first. And then after you divide by 5,000, we're going to log both sides. This will give you here 2.8. These cancels out. 1 plus 0.8 divided by 4 gave me 1.02 raised to the 4t. Now what we want to do, log both sides. To log both sides, we'll give you log 2.8 is equal to 4t log 1.02. Solving for t is going to be log of 2.8 divided by 4 log 1.02, which gave me an estimation of 13.003, or just simply 13 years. 17 is pretty easy. Again, the compounding here is monthly and equal to 12. So we started out with $15,000. And then this will be 1 plus 0.12 divided by 12. 12 month raised to the 12 times 6.5 years. You could do this all of it on the calculator, and I got this answer. 32595.557. If you want to round it to about 32,600 will be great. Okay, number 18. Number 18, I'm going to start out with PERT again. And I want you to know we're looking for the rate at which the bacteria is growing. So we want the bacteria to be 6,000 bacteria starting out with 5,000. We want to figure out the rate, and it took 2 hours. I want you to divide by 5,000, and I want you to natural log both sides. And so this is going to give us 6/5 equal e to the 2r, and then if you ln both sides, ln 6/5 is equal to 2r. Solving for r, which is ln 6/5, make sure you put these in parentheses, divided by 2, which gives you an estimation of 0.09116. Now we're going to try to answer the question. The question is, we want the final population to be 10,000. And we started out with 5,000. We already know the rate, which is 0.09116, and we're looking at the time. How long does it take to go through there? Now, if you divide by 5,000 on both sides, when we divide by 5,000 on both sides, you get a 2 equal e raised to the 0.09116t. ln both sides and divide by this number, 0.09116t, and you will find t to equal about 7.6 hours. And the question was when? When will the time be? So it will be probably from noon. From noon it will be 7 p.m. and then 60% of the hour will be 36 minutes. Number 19 is a pretty straightforward problem. Buying a car, it's not an exponential decay. So I'm going to use this formula. You started out with the price of the car at $11,000, and it decay at the rate of 16%, and we left it for 5 years, and you will know it is going to be 4,600.3, and this is option B. Number 20, again, it's a growth. We're doing an investment here, so I am not going to look at the exponential function. I'm just going to use the regular growth function. So we want to know the land. Now it's worth $12,000, and we want to look at the initial amount, and the rate is 0.09 for 8 years. And so now you calculate this number, which is going to be 1.9926, and divide both sides by it. 9926. This is what that is. And then you solve for A, and you find A is 6,022.395, which matches option A. 21, I'm going to use the formula A equal PERT. And they told you here in number 21, you started with 100 gram and ended up with 40.1. And the time took you to go from 100 to 40.1 is 12 hours, so it's going to be R times 12. I need you to find the rate at which it's decaying, so we're going to divide by 100. And so this will be 0.401 is equal e to the 12r. ln both sides, ln 0.401 is equal to 12r, and that means the rate at which it's decaying is going to give us a negative 0.0762. It makes sense that's negative because it's a decay. Next, we're going to try to answer the question. We want to look at the half-life. And the half-life, you're going to do it the same manner. We're going to do A equal PE to the RT. And so we want to start with 1. We want to end up with half of that. We already know the rate at which it's decaying, 0.0762, and we're looking for the time. ln both sides, ln 0.5 is equal to negative 0.0762t. And then if we solve for t is going to equal ln 0.5 divided by negative 0.0762, which gives me a time about 9.096, or simply put is 9.1.